All right, ladies and gentlemen, good afternoon to you all. Let me do something here. My website, it's kind of odd. I got to see what's going on. If I go here in Safari, maybe if I reboot my laptop, things will be fine. But if I switch to Chrome, ironically, if I go to Chrome, I get my website. So it's saying can't find the server in Safari, but in Chrome we seem to be okay. So let me just go to Chrome here. You guys are not trigonometry. I have all these things for trig as well. 261. Guess I have to go home. Do you guys remember where we left off? Now this one can't. Yeah, let's see. Yeah, let me see if I can get this here. I know I get it on the PC here. 261. Reload. Well, we'll see when I get home what's the deal. Okay. So we left off with this called critical values. You guys remember? So we need a critical value, a critical number. It's a number that's in the domain. This is something that's going to be overlooked by some. It has to be in the domain of the function. It has to be a function that's defined on the curve. But if the derivative equals 0 or the derivative does not exist, then we say that is a what? Critical value. This is the number C. We call that number a critical value. So I wanted to share with you guys a video where I have extra examples. But I think I showed you guys last time. So let me try this out. Let's get some functions here. And we're going to try to find some critical values. Is that right? So I'm going to say determine the critical values here. So let's look at some examples. All right, I just want you guys to know what's in the domain of this function. It looks like all real numbers, right? Everything works. You got the cube root function. And you got this, let me double check, see if we're okay. All right. So let's find the derivative. We're looking for critical values, okay? So you're going to differentiate x to the 1/3 minus x to the minus 2/3. And again, the derivative of a difference is difference of derivatives. Okay, now what do you guys use for each one of these here? Power rule, is that right? Okay, so we're going to say power rule for each one. All right, so by the power rule, you get what? 1/3 x to the 1/3 minus 1 minus negative 2/3 x to the negative 2/3 minus 1. Okay? So replace this one with 3/3. 3/3, let's do some arithmetic. We get 1/3 x to the negative 2/3 plus 2/3 x to the negative what? 5/3, okay? And this is one of the reasons why I wanted to find my website, to be honest. Because I do have a video there as well for this kind of question here. Okay. This is the derivative. Now, remember, we have to set this equal to 0. Okay, remember, what's your game plan? Ideally, you take that derivative, you set it equal to 0, or you let that derivative, you find where it's undefined. But the problem is now we're going to have to use some what here. And I do have a video on the algebra for calculus students. Here, let me see if I could reference it on this computer, because I can. I'm not going to go back and forth, though. Critical values. Well, let me see if I can over here really quick. Let's see if it... Maybe not. Forget it. I'm not going to... Okay, well... I'm going to try to put the name of the video for now and send it to you. What is it called? Algebra for calculus students. Yes. So the video on my website's Algebra for Calculus Students. Because what you have to do, ladies and gentlemen, on this one is factor out the what? Greatest common factor. And so you start with the constant 1/3 and 2/3. What do you guys think you can factor out here? Yeah, you factor out the 1/3. Okay. Now, you always factor out the x with the smallest power. So you're going to have to know what power is smaller. Does anybody know what power is smaller? You say, what do you mean? Where are the powers here? You got -2/3 and -5/3. You're factoring out the greatest common factor. So it has to be x to the smallest power here. And then you're going to multiply it by some quotient q. Okay, that's in that video, and I wanted to reference that, but I can't. So what's smaller, -2/3 and -5/3? Which is further to the left on the real number line? Do you guys know what's further to the left on the real number line? I think that's -5/3. Is that true? Now, how do we get this thing called the quotient? Do you guys know? How do I get my quotient? So in that video that I have, and that calculus for algebra for calculus students, I share with people how to get that quotient. It's the original question. The original, what you have, 1/3 x to the -2/3 plus x to the -5/3 divided by the GCF. That gives you the quotient. And in this case, the GCF is that 1/3 x to the -5/3. So the quotient will be 1/3 x to the -2/3 over 1/3 x to the -5/3 plus x to the -5/3 over 1/3 x to the -5/3. So this quotient we're going to find, and I think that was, there was a 2/3. Okay. So algebraically speaking, that's x to the -2/3 plus 5/3 plus 2, because this cancels here. 1/3 divided by 2/3 is 2. So the quotient becomes x to the 3/3, which is 1, plus 2, the point I'm making is that derivative is 1/3 x to the minus 5/3 times x plus 2. Okay, that's where we get that quotient down there in purple. This is the quotient. And I described that in my video, Algebra for Calculus Students, and I have people look at some of those there, because this is where people have to learn how to do some algebra. And you say, Mr. Judge, are they going to make me do algebra and calculus? And I'll say, oh, absolutely. And then this first derivative can be simplified even further. And you say, well, what do we simplify that as? Well, that derivative is going to be x plus 2 over 3 times now x to the 5/3 power. And if you want to go further in that video even, you say, can you simplify the power? Yeah, that's a mixed number. If you guys recall, and you get x plus 2, what is that? Isn't that 3x to the, what is that? X to the 2/3? Is that right? Mixed number? I think it's x squared. I apologize. Yeah, it's going to be x squared x to the 1/3. So here's the derivative. 3x squared cubed root of x. Okay, so this is kind of a good example for a few reasons here. Okay, remember, what do you have to answer to be a critical value? This is only part of what you have to do. Meaning you got the derivative. What do you have to do with the derivative now? Yeah, you might say, Mr. Judge, do I have to do this algebra? Well, you're not going to be able to answer the question without it. Because you want to know, where is that derivative equal to 0, or where is that derivative does not exist? And you have that situation where you have a numerator and a denominator, right? Here's the numerator, and here's the what? Denominator. So the derivative equals to 0 happens only when x plus 2 equals what? 0. Which means x is negative 2. Okay, so we say, okay. And then the denominator equals 0. That tells you where it's does not exist, the derivative. So you say 3x squared cubed root of x equals 0. Well, that happens when x is 0 here. Okay? By using more of that algebra, the zero product rule. So remember, I made those videos for people, the zero product rule. Hopefully people looked at that, because now you're in this situation where you're going to have to see how to simplify that derivative, because you're looking for critical values. So it's not enough, and this is what some people stop. Some people stop right here with their derivatives. And they're not going to answer the question. They're not going to find critical values. They just stop right there. So you're going to have to do some of the algebra, because they want a critical value. But then even more, you're going to have to know the definition. You say, what's the definition? Those numbers have to be in the domain of the function. So you might say, okay, what's the problem? What's the domain of that function here? Well, it's all real numbers except what? X cannot be what? 0. 0 is not in that domain. Does anybody want to tell me why it cannot be 0? Right? Why can't you have 0 here? You say, is that a detail? It's a detail. X can't be 0. Why can't you have 0? Isn't the problem right in here? What is that from algebra? Isn't that 1 over what? If I can get a pencil, isn't that 1 over x to the positive 2/3? That portion here? You can't have 0. Okay, and so what does that mean? It means this is not a critical value. It means the only critical value you have is x is negative 2. And there's an example of finding critical values, ladies and gentlemen. That's the gory detail that you have to be aware of, the definition and the algebra in addition to calculus. And like I said, I do have a video on that. I'm looking at it right now. Factor out the greatest common factor for all these kind of examples that you guys might see here. But this is, again, an example of how to find some critical values. Okay, anybody have any questions on that one?
So we have to solve the denominator and also the numerator, right?
If you have a fraction, yeah.
Okay, thank you.
Essentially, you have to know where's a function not differentiable. And that was on test 1. All those little things that we went over, we did it for a reason. This all fits together, ladies and gentlemen. It's not, yeah, it fits together. So it's like the example I left off last time. You said to me, let me go back and just reiterate this max and min, right? This one. You say, why is the critical value at negative 6? Because that derivative does not exist at negative 6. That was a test question. But is the function defined at negative 6? Say yes. The absolute value of 0 is what? 0. The function is defined at negative 6, but it's not differentiable. So that means it's your what? It's your critical value. That's why we said negative 6 was a critical value last time for the absolute value function there. Okay, but it has to be in the domain of the function to be a critical value. Yeah. So another example would be just a simple example to illustrate that idea, to pay attention to the definition. Okay? I'm going to give you a note, not an example. You might say, what about this nice function, 1 over x squared? Okay? And you're looking for critical values. You say, do I differentiate the function x to the minus 2 by the power rule, and I get negative 2x to the negative 3, which means my derivative is negative 2 over x cubed. And then you say, Mr. Judge, here's the derivative. And I'll say, yes, it is. And then you might turn around and say to me, to find critical values, I notice that my numerator, I set my numerator equal to 0. I set this, remember, the derivative has to be 0 or does not exist. Okay, by definition. And so, for the first part, well, the first part really implies that negative 2 is 0. The second part says x cubed is 0. So here, this is not what? This does not happen. At negative 2, the numerator could never be 0. We're looking at it that way again. Can the numerator be 0? No, this never what happens. It doesn't contribute to the answer. Hey, guess what? X cubed is 0 happens when x is 0 because you're looking through the same. Let's get the right green. Okay. But what's the problem here? I'm going to have to throw this out. Why do I throw it out? Because this function is not defined at what? At 0. So to be a critical value, you have to be in the domain of the function as well. So you might say, well, what does that mean about this curve? It means there's no what?
There's
Critical values. That's what it means. So I want you guys to know the definition. It's not just the derivative, it's the definition. That doesn't have any critical values.
Professor,
Yeah.
why can't we use like -2?
Why can't you can use negative, if you're talking about the prior example, the only critical value you have is -2. We can't use 0 because the function is not defined at 0.
I'm talking about the example.
This example, well, what are we saying here? If you set the numerator equal, if you set that fraction equal to 0, you say, what's the logic here? A fraction is equal to 0 only if the numerator is 0. And what you're saying is -2 equals 0. And that's not true. So in other words, if you see this, that information doesn't add anything. It's done. It's not a true statement. So that's what that means. Anyway. All right, what do you guys think? Just want to cover a little bit of the details there. And then let's look at another one. How about if they give you this function? I don't want to do, I want to make sure you guys get a little bit of that. I can't find it. Like, oh, where are you at? Critical values. Okay. Did I? No, I didn't do that one. Okay. X minus 1. X squared plus 4. You're going to try to find some critical values. Okay. Well, I'm just kind of curious. What's in your domain? It's all real numbers. How do you guys know all real numbers are in the domain? Every real number will work. Could the denominator ever be 0? Nope. Why not? Right? Your concern here for any rational function is the denominator. That could never be 0. You say, why not? Set it equal to 0. You say x squared will be -4. What do you guys get? You get complex numbers. You get complex solutions. So this is calculus of a real variable. We don't have a calculus of, we do have a course called calculus of complex numbers. We're not there yet, but you don't have a, that means all real numbers work for the function. So when you proceed with the derivative now, okay, what do you guys remember you have to use now? Yes, quotient rule. Did you guys invest in quotient rule? I hope. So we get what? X squared plus 4. Differentiate x minus 1 times x minus 1. Differentiate x squared plus 4. So, what's the derivative of x minus 1? Isn't that 1? And this is 2x. So by quotient rule, we get x squared plus 4 minus x minus 1 times 2x, x squared plus 4 squared. And so do some arithmetic. I think that's minus 2x squared plus 2x, everything over what again? X squared plus 4 squared. And it looks like I get minus x squared plus 2x plus 4 over that x squared plus 4 squared. Okay. Now, here's your derivative. Now, you guys remember, what do you care about? Well, we care about two situations, right? It's a fraction. So we're going to set the numerator equal to 0 And we're going to set the denominator equal 0 because we need that derivative to be what again? We got to find where that derivative is 0 to be a critical value. Or where the derivative does not exist. So the first equation, we get negative x squared plus 2x plus 4 is 0. The second equation, we get x squared plus 4 squared is 0. Okay, you guys okay with that one? Okay. Now, I'm going to say this to you guys. This never happens. Okay? You could never have x squared plus 4 squared equal to 0. You say, why? Because that means x squared plus 4 has to be 0, and we know that never happens either. So this portion does not contribute to the answer. So we throw that part out. Isn't that the green part, right? Okay, so now the orange part, we get a nice quadratic equation. Now I can fix this. I can say that this is x squared minus 2x minus 4 equals 0. Is that right? I can try to solve that one. But what do you guys know about this? It's not what? It's not factorable. How do you guys know that's not factorable? Because you're trying the crisscross method. Two numbers multiply together whose product is negative 4, but the sum needs to be what? Negative 2. You're trying the crisscross method, and what's the deal? Can't find any, right? So if you can't find a pair of numbers whose product is negative 4 and whose sum is negative 2, it is not factorable. Okay, but everybody's favorite what? Quadratic formula. Okay, so the quadratic formula says this is negative 2 plus or minus square root negative 2 squared. It looks like I'm bringing everything down here. Minus, right? 4 times 1 times that negative 4, which is C. Double check, because I had to go get some coffee. 2 plus or minus square root 4 plus 16, everything over 2. 2 plus or minus square root of 20, everything over 2. Simplify that, right? Simplify the square root of 20. Isn't that 4 square root of 5 over 2? 2 over 2 plus or minus 4 square root of 5 over 2. So x will be 1 plus or minus 2 square root of 5. So these are the two what? Critical values. And I think I made a mistake. In fact, I know I made a mistake. This is 2, and this is 2, which makes this 1. Let's undo that. I'll bring it over here. All right. So, ladies and gentlemen, you found your what? Critical values. Square root of 5.
Oh, sorry.
Critical values, ladies and gentlemen. You want to take a look? So this is some of the algebra that they expect you guys to remember in a calculus course. Okay, everybody okay with that one? All right, all real numbers, and those are real numbers. Okay, good. What if they give you, excuse me, yeah, I want to be careful here. Okay, I'm going to give you guys, 4x minus tangent x, and they're going to say now over the interval 0 to what? 2 pi. Okay, you guys okay with that one? All right, so let's find this derivative here. So we're going to say, let's take the derivative of 4x minus what? Tangent x, which is two derivatives here. The derivative of a difference is difference of derivatives, right? So what's the derivative of 4x? Isn't that going to be what? 4. What's the derivative of tangent? Secant squared x, okay? All right. Okay, so if we're going to set this equal to 0 here, we got secant squared x minus 4 is 0. So what does that mean? Is that 4? So then secant will be plus or minus square root of 4. Is that right? Or we say secant is plus or minus 2. Double check from your algebra here. Okay, now I want you guys to note something here because we're going to get back to this. In fact, if you had, well, let's do this. If you had to solve for secant being plus or minus 2, what does that imply? Do you guys know? Those of you guys that took trig, the reciprocal of secant is actually cosine. So you take reciprocals. Is that right? And so I do have those trig equations. I think I did send that to you guys already. So here's our two solutions. Okay. So cosine is positive 1/2, or cosine is what? Negative 1/2. Is that true? Okay. Now, how do we think about this? Do you guys remember? Let me bring in a picture. See if I can. I think it's here. I'll pretend this is my trig course. Okay, so where is secant positive? Yeah, maybe I'll color it. You got cosine 1/2. So quadrant 1 and quadrant what? 4. You guys okay with that? And so I think you have to go back to the reference angle. So let's go back to the reference angle. So I just want to be clear here. Isn't that where it's positive? And where is cosine negative? Quadrant 2 and quadrant what? 4. Okay. So let's go to the reference angle, which is really the quadrant 1 angle. So back in trig, we have to draw a triangle, if I remember. What triangle is this? Adjacent over hypotenuse. Is this 1, 2, square root of 3? So what's the angle? Anybody remember what angle is that? Is that 60 degrees? Is that pi over 3? Is that right? 30, 60, 90? I'm not awake, but I think that's okay. That's your pi over 3. This is 60 what? Degrees. Okay. So the quadrant 4 angle, that's the reference angle, 60 degrees, right? So for quadrant 4 now, we're going to say, how do you get this angle here? Well, x will be 2 pi minus that pi over 3, if you guys remember. And that means it's going to be 6 pi over 3 minus pi over 3. What does that mean about x? Is it 5 pi over 3? And that's your second solution. And the first solution is going to be what? Pi over 3. So you're solving the trig equation. What about in red? You say, what about these other solutions? Well, that's 60 degrees. So cosine's negative. 60 degrees. This is cosine's negative. Is that right? And reference angle. Reference angle. So this third solution, if you want to call it that, would be pi minus your reference, and that'll give you 2 pi over 3. Is that true? So this is a trig, solving trig equation. Okay. Quadrant 3, x4 is going to be pi plus the reference of pi over 3. If you guys recall, and that's 3 pi over 3. So x4 is going to be what? 4 pi over 3. Okay. So far, if I had to list these solutions here, right, x will be pi over 3, 5 pi over 3, 2 pi over 3, and then 4 pi over 3. And that's where secant is plus or minus 2, or secant is plus or minus 1/2. Now let's go back over here. Let's think about the domain here. Tangent. What do you guys remember about tangent? Anybody remember about tangent? What do you guys know? What can x not be? Tangent has vertical asymptotes. X cannot be what? Let me think about that. Do you guys remember? Pi over 2. What else? X can't be 3 pi over 2. Because the interval that's restricted is 0 to 2 pi. Double check. I think I'm correct. Is that right? So does that mean that these numbers are critical values then? Yes, good. Critical values. Good. Okay. However, do we have any other critical values? Go back over here. We got to be concerned. What about secant? What do you guys know about secant? Where's cosine? Where is cosine 0? Do you guys remember? Because what we checked here is where this derivative equals 0. Is that derivative ever does not exist? What values of x does that derivative not exist? Do you guys know? What do I know about secant? I have a problem at secant, don't I? I think it's the same for tangent. Is that true? Pi over 2, 3 pi over 2. So we're good. Here's the point. We're done, ladies and gentlemen. If I can draw a... whatever. Jesus. Jeez, my website's down and what the hell? Anyway. Let's give you guys another question. I don't want to do the ones on my worksheet. Should we try that one, or should we try an easier one? How about x cubed plus x squared x cubed plus x squared plus x, maybe? Did I try that one? Okay. What do you guys know about this function? It's a nice polynomial. What's in the domain of this function? Do you guys know? All real numbers. So we're good with all real numbers there. Okay. Let's find that derivative. Okay, so the derivative of a sum is sum of derivatives. Okay, so what's that going to give us? That's going to be what? 3x squared plus 2x plus 1. Okay, so that's a nice polynomial. So, you know, it's never does not exist, right? It's defined everywhere. So we just have to check to see where that derivative equals 0. So I get this derivative. Where is it equal to 0? Well, let's set that equal to 0. Okay. Here's a nice what? Can we do crisscross here? What does the product of the numbers have to be here? It has to be 3 times 1. Remember, A, B, C, 3 times 1 is 3. And then your sum has to be B. Is that right? Okay. This will work by the crisscross method. So, ladies and gentlemen, what do we get now by the crisscross method? Two numbers multiplied together is 3. When added is 2. What's that going to be? Does that work? that two numbers multiplied together is 3 when added is 2? Uh-oh. Do we have to use the quadratic formula again? Are there two numbers that'll work? 3x squared plus 2x plus 1. Let me double check. Well, it is in the book, but let's make it. Oh, let's pretend there's a typo. Yes. We did give a quadratic formula example, so let's pretend. But this is actually in the book, so you guys know. Okay. Will this help us? Two numbers multiplied together is -3. When added is 2. What do you think the numbers should be? +3, -1. Okay. Oh, I think you're right. So let's be careful here, okay? So by that crisscross method, we're going to have to remember an important detail. Don't forget A here. Did anybody watch the video by any chance that I did for you guys? Anybody watch that? What do I mean by this? Yeah, we're going to have to divide both of these by 3, okay? Right? Because A is not 1. A is 3. So, okay. And if you get a nice whole number, then you're fine. Like 3 divided by 3 will be what? 1. So by the crisscross method, you get now what? X plus 1. And then over here you say, though, what's the problem? Oh, you don't get a nice whole number. So what do you guys do in that case? Do you guys remember? Bring up the 3. So this is 3 what? X minus 1. So let's make that 3 nice and what? Clear. Now this is equal to 0, right? So you just set that equal to 0 and use the 0 product rule. So x plus 1 is 0. 3x minus 1 is 0. And this means x is -1. And this means x is positive 1/3. So that algebra was designed to help us. These are all critical what? Critical values. Okay. And I don't remember if I gave this to you guys last time. Did I give you Fermat's theorem? Yeah. Thought I did. Okay. So let's give you the closed what? Interval method. Okay. So they're going to give you a nice continuous function, ladies and gentlemen, over a closed interval, AB. Okay, so they're going to say this. Let f be nice and continuous over, that's the closed interval, by the way. Okay, that just means include the endpoints. So you're going to have a nice, and so here's what happens. Then you can determine we call an absolute max and min over the interval. So you get to find a max and min over the interval. So here's what you really have to do. Here's the idea, okay? So first of all, you have to first determine the critical values of the function f over that interval AB. And that's an open interval, so you guys know. That just means you don't include the endpoints. So, open interval. Okay? Second thing is going to be the following. Determine the values of f at the critical values and the endpoints. A and B. And then here's your conclusion. The largest value in step 1 and 2 is the absolute max. And I think the other day we colored it purple. So all they're saying is the largest value in steps 1 and 2 is the absolute max, and then the smallest value in step 1 and 2 is the absolute min. It's called the closed interval method. And I have 3 examples on my website, but let's give you guys a nice example. We'll take one from the book, but I have 3 on my website. I don't want to do those. Okay, how about 2x cubed minus 3x squared? Minus 12x plus 1. And then they're going to give us the interval. Negative 2 to 3. Okay, we're going to use here the closed interval method to find the absolute max, absolute min over the interval. It's very simple. What do you think your first step will be? Find your critical values. So it's a nice polynomial. It's defined everywhere so that means whatever I get as a polynomial, I set that equal to 0. So, do you guys want to tell me what that derivative is? Can you guys see taking derivatives now is the least of your what? Concerns? So what's this going to be? Isn't this going to be what? 6x squared plus what? 6x minus 12, I guess? Is that right? You guys okay with that? Okay, what do we have to do with this? Set it equal to 0. And you say, Mr. Judge, how come that thing is never, does not exist? It's a polynomial. Okay? Differentiable everywhere, right? So I'm going to divide every term by 6. You know what I get? I get x squared minus x minus 2 equals 0. Okay. I'm going to factor the old-fashioned way. If you have to use a crisscross method, please do. Okay, use the crisscross method if you like. And now you're going to get what? X minus 2 equals 0, and you get x plus 1 is 0. And this means x is 2, and this means x is negative what? Negative 1. I got my critical values. Okay, good. So easy peasy, lemon squeezy. You got the critical values. You guys okay with that one? All right, now let's remember what A and B are. Don't know what colors. Here's A, here's B, okay? -2 and 3. So I have to evaluate the following. This is what that means. F of -2, F of 3, and I got to evaluate the value of the function at the critical values. F of -1. Because remember, my interval is from -2 to +3. And then notice that these critical values are in that interval, by the way. Okay? So -2 here, +3, and then the critical values. And whatever is the largest number is the absolute max. Whatever is the smallest is the absolute what? Min. So what's the function again now? F of x. What's that original function? Oh, 2x cubed minus 3x squared. And that's minus 12x plus 1. So if I plug in the -2 first, okay. Got 3 times -8 minus 3 times 4 plus 24 plus 1. -24 minus 12 plus 24 plus 1. So double check. I think this is -11, okay?
For the first term, you put 3,
Two.
-2 to the power of 3, it's 2 -3 to the power of 3 for A.
Oh, thank you. Thank you so much. I'm trying to be quick about this. All right, so what does that mean? We're going to get what? Negative. Is that -28 plus what? -4 plus 1. Is that -3? Double check. Did you guys get -3 here? Okay. Now let's plug in 3. So if we plug in 3 now, let's see what we get. What's 3 times, isn't that going to be 27 times 2? Is that 54? Minus, that's 3 to the third now. Is that 27? Minus 36 plus 1. So we get 27 minus 36. Is that negative 9 plus 1? Do we get negative 8? Double check, you guys. I'm still drinking my coffee. Double check my arithmetic. Let's plug in 2 now. F of 2. 2 cubed. Is that going to be 8? 8 times 2 is 16. Minus 9 times 3. Is that 27? Minus 24 plus 1. It looks like it's negative 11. Negative 35 plus 1. Double check that this is negative 34. I'm not even awake. And now let's plug in negative 1. I'm not awake yet. So f of negative 1 will be 2 times negative 1 cubed minus 3 times negative 1 squared minus 12 times negative 1 plus 1. So it looks like that's negative 2 minus 3 plus 12 plus 1, negative 5 plus 12, 7 plus 1. Is that 8? So double check to see. Now, which one is the maximum value on the list? 8. So we're going to call this the what? Absolute max. Okay, which one is the minimum value? Negative 34. This is the absolute what? Min. Over the interval, negative 2 to 3. So, you know, we can double check that in Desmos. We don't have any time, though. You know, what is that? 2x cubed minus 3x squared minus 12x? Does Desmos even work? That 2x cubed minus what? 3x squared. What is that? Is that minus 12x plus 1? Okay, and I know we have... And then the interval, what was that interval? Do you guys remember? From negative 2 to 3? Okay. So I'll put negative 5 to 15 maybe. Anyway, so double check. Is that the right function? 2x cubed minus 3x squared minus 12x plus 1? Cubed minus 3x squared minus 12x plus 1, negative 2 to 3. Well, here we go. Anyway, here's the idea behind the closed interval method. If you guys can see that here. Did we get negative 1 as a critical value? We did. So it looks like the absolute max is actually 18, but the absolute min is what? Negative 19. So double check our arithmetic. Happens at 2 and then negative 1. So double check, ladies and gentlemen. Desmos says, okay, 1, 8, 2, 9, negative 19. So, okay. There we go. Should be negative what? 19. Okay. Trying to hurry to get this in, because I want to double check and show you guys exactly a picture of the closed interval method in Desmos. And let's do maybe a little better there. Okay? So that's actually a picture of a nice continuous curve over a closed interval. And what they're saying is You're going to have an absolute max, absolute min in the interval. It'll happen at some value at the critical value or at the endpoints. Because it depends on what the endpoints is. What if the endpoint was a -1? You know, what if it went up to -1 to +2 or something? So it'll happen at the endpoints. So that's a graphical picture of the closed interval method. So I will put some homework. I'm sorry you can't see my website. I don't get that here. You guys are Math 261. I will put some homework on this for you guys. And assignment 3. So double check as soon as you can. And I'll see you guys tomorrow. Okay, take care, stay safe.